Okay. So what we're going to see here, and this is going to maybe trip you up a little bit, is that m is going to be equal to this 1/2. So when you have v1 over 2, it's the same as saying 1/2 times v1. Okay, so our m becomes this 1/2. So now we have v prime is equal to 1/2 v1 plus v2 over 2. Does that make sense?
So that's our slope?
Yeah, so our slope is 1/2. That's question number 1. Yeah. There's a B. It's only this big. It's just this little line right here. You're all good. Okay?
I'm already at the bottom of my page.
So slope, which I forgot the E, is going to be 1/2. So y equals mx plus b. Because up here we said x was v1. Okay? All right. The second question asks us to figure out what the velocity is. Use the graph to calculate the velocity of cart 2 before the collision. So it's asking us to figure this part out here. So we see that B is equal to V2 over 2. So 2B is equal to V2. When we go back to the graph, we are given the y-intercept. Okay? Either on a diploma, you're either going to have the information and you can use your calculator. Remember we practiced that to figure out your y. When you do your slope intercept equation, it gives you x, y, it gives you m, and it gives you b.
So 1 is equal to this.
So b is equal to this negative, because it's below 0, negative 0.23 centimeters per second. Make sure we're aware of that. Okay?
Why is it?
Why what, Jayden?
Why is it under below the graph?
Because it's not set to 0. When you draw your line of best fit, your line of best fit doesn't go through 0. So where it crosses the y-axis is below 0, so it's negative.
I was looking at the x-axis. That makes sense.
Y-intercept, which is b.
Yeah, I know. It's a lot. I get it now.
Okay, good. I'm glad, because I was like, I don't know another way to explain it to you. So we see that it's going to be 2 times negative 0.23 equals V2. So V2 would be equal to 0.46. 0.46, this negative sign here
Two negatives? Like, wow.
tells us what?
It's going in a negative direction.
What's another way of saying a negative direction?
Never you soggy south, down.
Opposite
Opposite, sure.
of cart 1.
Where's it going?
Opposite of cart 1.
Ah.
That's what the negative sign says. When we have no directions, we were never told left or right, up or down, east or west. Yeah, but we weren't given those directions, so if we have a negative sign, it always means opposite. Okay? Clear? Clear as mud? Mud?
I'm hungry.
Okay? So you would probably be given something like this. You would have to draw your line of best fit, plug it into your calculator. You can extrapolate points from here. Okay? They're pretty much at all the intersections, with the exception of the first one. Okay, so let's look at the second one. A practice problem. A student is performing an experiment that's related to momentum. The student used a two-cart system where two carts collide and stick together after the collision. Cart 1 has a mass of 1.54 kilograms, and the speed of cart 1 is changed each trial. Cart 1 will collide with cart 2, which is initially at rest. These are key words that we're picking out. The student then measures both the initial speed of cart 1 before the collision and the speed of carts 1 and 2 combined after the collision. Another clue of what that looks like. The following graph shows the speed of carts 1 and 2 locked together after the collision versus the initial speed of cart 1 before the collision. So you can see from the graph that it's speed of cart 1 and 2 on the y-axis in centimeters per second. And you can see that speed of cart 1 on the x-axis is also in centimeters per second. Okay? So we're going to start at the bottom of this graph, and then we're going to do the whole other page. Okay? Just so you're aware. Those of you that get frustrated when we're at the very end of the page. Okay, here we go. So, what's the thing that we do first? Draw a picture of what's going on, right? Always do a before and after. And I will remember to put the T in. Always do a before and after. So before we have cart 1, and we have cart 2, and after they're combined together. And it says in here, we don't have directions. We just know that this is going one way. Cart 1 is colliding into cart 2, and we know that cart 2 is stationary, right? Mass, we're given the mass for this, 1.54 kilograms. Velocity 1 we get from the x graph. This one is 0, right? It said it's initially at rest. And we know that momentum before is equal to, oh, the smartboard does not like this part of the board. Okay, after they're together, so their masses are combined, and their velocity is off of the y-axis. Okay, and we know that after momentum prime is equal to m1 plus m2 times v prime. That's what we know beforehand. All the information. So same thing that we've done all these years along is that we've always written down what we know. Okay. So what we learned yesterday, conservation of linear momentum. We know that the sum of the momentum before is equal to the sum of the momentum after, or instead of writing after, correct prime. Okay? So we have m1 v1 plus m2 v2. However, v2 is 0. Right? So that's where we're at when we're looking at the sum of momentum before being equal to the sum of momentum after. Alright, blank page. Carrying on. So, we know okay? And it's asking us use the slope of the graph to calculate the mass. That's our end goal. Okay? So, we have and V prime is a piece of information is Y. So we need to isolate Y out. And we know that V1 is X. So if we isolate out our slope, I'll just do this. So V prime, our slope here, because we need VI by itself, is going to be M1 divided by M1 plus M2. Plus B, and we have no slope when we look at the graph. When we go back and we look at the graph, we see that it crosses through 0. So this is going to be 0.
Solid.
Okay, so this is our Y, this is our M, our X, and our V. That's what our slope is of this particular graph. So when we look at the graph and we take 2 points on the graph, right here, because we want to take them where they cross the intersection at.
Oh no.
Oops, not plus.
I think your line just straighter than mine.
My lines are.
Yeah.
So Y2 comes out at 3.4, give or take, and Y1, so this is Y2, sorry, Y1 comes out at 2.2, X is 5.0 minus 2, 3.2. So what do you get for a slope value?
Six repeating.
6 or 0.6?
0.6 repeating. Yeah, that's what I meant.
1.2 divided by 0.18.
Yeah.
All right, 0.6. I've got that right here on my notes. And what's the units going to be?
That's up to you to decide. centimeters per second, maybe?
Okay? 0.6. So here, when we go to figure this out, I'm just going to move this up here.
Well, our slope is m1 divided by m1 plus m2. No, that's divided by mass. Our thing is 1 over mass. That doesn't make sense.
What?
Never mind.
So we have 0.6 times 1.54 plus m2 is equal to 1.54. So what is 0.6 times 1.54?
Go, Reese. Put it on the spot.
1.026 review.
Good job.
What's 1.54 minus 1.026 repeating?
Go again, Reese.
0.513 review. Uh, 0.769 review.
Hang on, Harvey's. I have a different number.
Uh-oh.
I'm just going to figure this out.
Oh, I'm bleeding. A lot. I was wondering why my nose is so runny today. What?
Hey, could I go to the bathroom?
Yeah.
Oh, that is a lot of blood.
Don't do that.
Don't take it back.
You don't do that. It's gonna go to your
Okay.
brain.
That's going to run back down his throat.
Alright, so we get really close to the answer that I originally calculated, but if we do it the way they calculated it out, we don't get that answer at all. So here we did m1 is equal to slope times m1 plus m2. And so when you just do factoring, you have slope times m1 plus slope times m2. And our slope from the graph was 0.6. 0.6 times 1.54 is this times that is that. And you subtract that, this value here from 1.54 and then divide it by the 0.6 to break out m2. You can do it another way. you can go slope equals m1 plus m2 and leave this as a whole unit. And we know that if we were to do distance equals velocity over time, if we were looking for time, we just switch. Time is equal to velocity over distance. Right? We know that part. So if we just switch these two around, we have m1 plus m2 is equal to m1 over slope. And then we would have the 1.54 divided by 0.6 is equal to 1.54 plus m2. So then you would take this value here and subtract it from 1.54 and you actually get 1.02 kilograms. I'm not sure of why the discrepancy.
Sure.
So what I did, I'll bring this down further. So up here, I'll rewrite it so that we can see it, okay? We did the math this way, where we had right? And then we did slope times m1 plus m2 is equal to m1. So that means when we do the factoring, we have slope m1 plus slope m2 is equal to m1. Agree so far? Okay, so this was 0.6 times 1.54 plus 0.6 times m2 is equal to 1.54. This one gave us 1.026 according to Reese. We want, this is what we're looking for, so 0.6 m2 is equal to 1.54 minus 1.026 is equal to m2 would be equal to that divided by 0.6. So when you do that, you get the 0.769. Do you agree with what Reese did for his math? Okay, so 0.769 kilograms. Now, there's another way to do it. Slope is equal to m1 over m1 plus m2. And m2 is ultimately what we're looking for. So if we go slope times m1 plus m2 is equal to m1, and we get rid of slope right away, okay, do you see that part? Okay, because I'm leaving this as a whole unit. So now we have, for M2, isolating for M2. When we do this math, 1.54 divided by 0.6 minus 1.54, by my calculations, and maybe I'm wrong, but I've done it twice, I get.
Are you in degrees or radians?
I'm always in degrees. I don't teach radians, so I don't take the calculator out of it. Do you see where the confusion is? So I'm not.
So they just did like a different way of isolating.
Yeah, but when they did it by calculator, they got sorry. Oh, they got a I don't know why.
What they get?
They got 0.68, and when they calculated it out by calculator, their slope was 0.6945, and when they calculated it out by hand, like we did, they got 0.6. So I'm okay with this number here being different than what we did because the calculation goes through by calculator, which is fine. And when you do the diploma, they will tell you, it will be, this would probably be one of your numerical response questions, and they would accept 2 answers. They would accept, they will have done one by hand, and they will have done one by calculator, and they'll know that there'll be 2 answers. And so if you were to have put down 0.68 by calculator, you would have gotten full marks, and if you would have put down 0.769, you would have gotten full marks. My question is this discrepancy here. Because they don't go back and look at your work. I'll have to ask, that's a Mrs. Goodall question.
It's kind of weird that the 1.026 is the same as the answer your answer, but we used it as a calculation for the other side. If the 0.6
I know, so I don't know, Joes. Okay, another practice problem. Actually, I'm going to give you the rest of the class to work on the first questions, and I'm going to give you this now. It's not for homework, but you'll have it for tomorrow. We can start off class doing it tomorrow. I will.